All right, so we did our project on the Yelp dataset. For this project, our goal was to, or this part of the project, our goal was to predict how an individual user would rate an individual business. So for this, we had three different databases we wanted to look at. The first one was information about the user. So this tells us, the user's average star rating, um, various other variables about the user. We had a database about the business the businesses that were being rated here. So it gives us attributes such as whether it's a restaurant or not, um, where it's located, etc. We also had a database full of reviews. These were a review of an individual business by an individual customer. Our first step was to do some data reduction. We wanted to look at only reviews of businesses in the city of Las Vegas that were restaurants. This was about 800,000 reviews. Um, One of the things we added to the customer profile was we wanted to um, sort of cluster similar customers together. So we used a k-means clustering method to come up with clusters of users. We divided the users into 5 clusters and added that as a variable. Our next step was to, now that we had reduced the businesses to Las Vegas restaurants and we had added a variable to customers, we wanted to merge the customer, the business, and the review database all into one so that we could see for an individual review how the information about the customer reviewing and also the information about the business being reviewed. Um, so this was our final database with all that information. Um, Next step was to do some analysis. So the first thing we did was we took a look at decision tree with feature selection. So we divided this up into we divided this up into 3 different percentiles. The first one was a 35 percentile cutoff. This took us to a 41.4% accuracy rating. You can see here the variables we're still using. Next, we took a look at a 25 percentile cutoff. This drastically reduced the accuracy to 33%. And finally, we took a look at a 15 percentile cutoff. This reduces 3 variables, cool, funny, useful, and increased the accuracy to 41.3%. This suggests, especially compared to our decision tree classifier with no dimension reduction, that there may have been some overfitting of the data. You can see here the decision tree classifier with is 39.9% accuracy. Next, we took a look at a slightly stronger algorithm, the random forest. You can see here that we got 43.4% accuracy. Next was the LDA. This was a big jump in accuracy up to 47.3%. Finally, we looked at the AdaBoost classifier. This gave us a 49% accuracy rating. One thing we were worried about with the AdaBoost classifier was many of our variables were not normally distributed. So you can see here that this is our distribution of useful ratings. Now, most of the useful ratings were very close to 0, and several of our other variables had similar distributions. So we experimented with reducing useful, cool, and funny to below 1,000. This chopped off about 4% of the data from 838,000 down to 803,000 reviews. This gave us a 49.6% rating.
Okay, so I wanted to give a little snapshot of what I did for the final project. My focus was on the Yelp dataset, specifically the text analysis. So we broke down our data into Las Vegas restaurants. So I did a couple of visualizations with the length of the reviews here versus stars, and the ratings distribution in Las Vegas here in green follows kind of the same pattern as the full data set in brown here. So then breaking down into the text, the actual text of the reviews and the stars. The mean length of a review was 621. So I broke down the data further because it was still very large into into reviews between 400 and 800 words. So after that, it was time to tokenize the data using NLTK. I used some pre-processing techniques with that library to tokenize. So looking at, they did the lemmatizer, took out the stems, and then this just kind of gives you a counter of the words, most common words. And this one is before the stop words, so I imported the stop words and then took those out using using a little loop here. And so now we can see that the stop words are gone. This WA stayed in for some reason, and I was having some trouble getting that out. That was something that I wanted to work with more, but ran out of time. And then I imported GenSim, which is a really cool library. This dictionary function assigns each word a unique ID here. So you can create a corpus where it loops through each review and returns how many times each specific word occurs in that review. So here we can see that some of these words occur twice, most of them occur once, but each word has a unique ID in this review. So this is just kind of another count. And then GenSim does have an LDA model function, which I really wanted to explore more. There's a lot you can do with it. I specified number of topics, 15, just kind of for time, and so it breaks it down into topics, and each topic it kind of picks out. Here I narrowed it down into 8 words, so it sums up the topic of the document in 8 words, 8 main words. So you can easily run this model and get the major themes of the data out of it. It's a really intricate function that there's a lot you can do with that I didn't have time to explore, but I will be exploring. And then there's this really cool visualization that I made that kind of crashed my computer, so I will turn that in. I'll have that when I turn in the final project, and then use the TF-IDF model in GenSim, ran some sklearn models, and then also what did I do? Went through the examples in class, and this is over the full data set, full Las Vegas data set. So using the cross-validation function here, I got a score of 55 here. And then using calc params, running the multinomial Bayes and the SVC, we see here that we're definitely we have some work to do with overfitting on the test data or on the training data here. Training data, we're getting almost perfect scores. Test data, not nearly as good. Same with the SVC, but just a different pattern here. A lot of overfitting on the training data, but that was a quick snapshot of what I did. I'll have some more details when I turn in the project. Thanks.